Hey guys, what we're going to do today is we're going to calculate Hooke's law. We're going to look at how the extension of a spring changes with the amount of weight that we put onto it. I'm going to talk you through the experiment, how we do it, and hopefully we'll get some really good calculations, and hopefully you guys will be able to draw a graph for me. So here's the experiment equipment that we're going to be using today. This here is a retort stand with a boss and a clamp onto it. Now what we'll do is we'll hang the spring from this clamp here. Obviously we're going to use the spring. We've got a set of slotted masses connected to a hook. And we obviously need a ruler to measure length and extension. And obviously I'm going to need my trusty goggles. Now you may be thinking, why do I need to be wearing goggles for this experiment? Well, actually this spring can stretch. And if it stretches too much, it can snap. And it has been known to ping back into people's eyes. So this is just as a really precaution. I don't actually think I will definitely need them, but it's better to be safe than sorry. So you can see here that I've set up the boss and the clamp with the spring attached to the bottom of it here. And if I use my ruler, you can see that this spring has a length of 2.8 centimeters. I'm only taking the springy bit, not the bit with the loops as well. So here I'm just going to do a quick little table. Here the weight is obviously going to be 0 newtons. The original length of the spring, well, that we said was 2.8 centimeters. You don't need to write centimeters in here because the units is already written in the table up here. And then here for the extension of the spring, well, the way we calculate extension is by removing the original length from the length that it is right now. And the original length is 2.8, so 2.8 minus 2.8 is of course 0. We have no extension on the spring at this mass because there's no mass on it at the moment. Okay, what we're going to do to this is we're going to add a slotted mass onto here. So you can see that now the spring has extended because I've added a 1 Newton mass. And we're going to measure the length of this spring now. We can see here that that's 6.5 centimeters. So again here, the weight is 1 Newton, 6.5 centimeters. And now for this, we're going to have to do a little bit of calculation. So you may want to get your calculator out, but we're just going to do, if we do the working out, 6.5 minus 2.8. That is, of course, 3.7 centimeters. Now remember, you always subtract the original length. You don't subtract this length each time. You're going to always subtract 2.8 each time. And as we go up, the extension should increase by the same amount each time. All right, let's see what happens when we add a second one. So right now I'm going to take a second slotted mass. And we're going to put that slotted mass on here. Oh, there we go. And what will happen is that the spring should extend a little bit more. Let's calculate the length of this spring now. Here it's about 9.8 centimeters. So at 2, we've got 9.8 centimeters. So then you need to work out what the extension of the spring will be. So again, we're going to do 9.8 minus the original 2.8, which will equal, of course, 7.0. Now, let's get the rest of the results here. Right now, I've added 6 masses on, and we've got our data here. Now, I haven't added any of the extensions on because I want you to be able to calculate those extensions. So draw a table like this in your worksheet and fill in the correct extensions, and hopefully you'll be able to plot a graph of the weight on the x-axis against the extension of the spring on the y-axis, and you should get a really nice graph. Right now, if I remove this mass, then it will go straight back to normal again. This means that it's still elastic, but I can actually deform this really easily. Let me just show you what I mean. So if you put too much force on a spring, it will actually never go back to its original shape. Here, let me show you. If I pull this too much, then it's reached what's called its elastic limit. It will never go back to the same shape that it was before. All right, good luck with your investigations, Year 7. Have a good day.